report. Okay, then share screen. Okay, so today we will continue our discussion about linked list. Previously, we discussed two kinds of implementation. So we discussed two implementation of linked list. The first one is kind of simple, so we just have the node and then just try to get the node connected or removed. And yesterday's implementation that we discussed, a little bit of more complicated, is we add some iterable interface and iterator interface. And today, let's take a look. It's kind of more complicated because if you take a look at my today's package, I have 3 files. Okay, I have I call it my list Java file, and I then have my linked list and then the driver. So let's first take a look at the my list one. And right now, if you take a look at this my list, and this is not a linked list, okay? Because over here, if you take another close look, you will find it's an interface. So over here, I define an interface. The name is called my list, and it's also a generic one, okay? And over here, this interface extends the collection. And next week, we are going to discuss in detail about collection. Okay, so collection has a number of useful data structures. And the collection is also an interface. And yesterday, we also learned the iterable interface. Okay, so if we view it in hierarchy, collection, we can view it as the sub-interface of iterable interface. Okay, so basically collection also support iterator. Okay, so let's see this my list. What does it have? So because it's interface, is it? So here we have some method. So we just give the method header basically, and no implementation, is it? So the first it defines is set called add method. So this add method, but it's add at the specified index, is it? And the item you want to add. Okay, so that's the add function. And we also have the get. And I remember yesterday in our implementation, we discussed the get. Kind of, is it? So yeah, same concept. So this get function is if you know the index, and then you can get the item, okay? And the next one is called index of. So if you want to find an item where it is in your collection, okay, or like in the ordered collection of data. And the next one is called last index of. Okay, so it's fine. So in your data structure, you may have repetitive items, is it? But you want to know where the last one is. So this will give you the last index of. And then let's move on. Okay, then the next one called remove. And for this remove, it's you need to give the index. So it's a little bit different from what we saw before. Okay, remove the item. So this is you specify where it is, and then you remove the item. At the same time, it will also return the item that's going to be removed. And it also provide a set function, okay, method. And what this set method basically is going to change. So you find the item, is it? And then you are going to reset it to a new item. So that's what this set does. And now let's take a look at the next part. And then you you may ask a question, is it? Because generally, previously, what we learned, interface. And the interface basically just has method header. It's kind of like the abstract method. Is it no implementation? And the implementation, generally speaking, for interface is going to leave it to the concrete class, is it, who implements it? Is it who implements the interface? That's the concept of interface, is it? But over here, if you take a look, this method, so all of the previous method that we just discussed follow what we already learned about interface concept. Over here, let's take a look. This add method, is it, okay, you're going to add some item, is it, and return type, and the access level, is it, and override, we know that you can, because it's extend the collection, is it, so it can do some override of, because the collections library, it has, it's an interface also, it has a method called add, is it? And here try to override it. But over here, if you take another look, there is a new keyword here called default. Okay, see, this is also a Java keyword called default. And then if you take another look, you will find over here, this add method, it's implemented. Is it implemented in the interface? That's kind of contradictory with what we learned before. Is it interface supposed to only have methods that's not to be implemented? Is it? But here, this method, you implement it. Is it? So how that happens? Is it? So this is for Java, the interface later on versions, they also allow what we call this kind of method, default method. So basically in Java interface, we allow three kinds of method, okay, abstract method. So no implementation. Is it? And the second is a default one. Default method. But the default method must have the keyword default, okay, it's implement. And the third is what we already know, a static method. Okay, so that's regarding the interface, generally speaking. So this method is we define it as a default method. So if you define it as a default method, then you must provide the implementation. Okay, so the idea is to provide more flexibility for interface. Is it? Just think about it. If you define an interface, is it when you design that interface, you provide, assuming there is no default method allowed, is it? So then you just define certain abstract method, is it? Then later on, okay, some class implement it. They need to implement all of those methods, is it? But you know, sometimes when you define certain interface, you may not foresee some other specific method. Is it later on? Then you may say, oh, that method may be a very useful method for this interface. So how can we add it in? Is it? And if you update this interface, is it? Of course, you can do it. Is it with a new version? Is it interface and add some method? Then the problem is with all of the classes that implement this interface. Then they all need to be updated. That's going to be a hassle. So to avoid that kind of a hassle, a nice way to solve it is you can provide some method, we call it a default method. So you can flexibly as on update the new version of your interface. Okay, and with the default method, then it's not mandatory for whatever the class implemented they need to implement it again. Okay, so that's the as part for default method. Okay. So anyway, so here the major concept is in interface, we can also provide a method and we implement it inside the interface. And this kind of method, we call it a default method. So here we have a add default method. And what it does, you can see it's just to call the other non-implemented add method, is it? And that non-implemented version will purely depend on the concrete class, how to implement it, is it? So there's still some relationship in this case. And that's going to add, where add at the very back, okay? And it also provides these empty functions. It's also a default method in this case. And let's see, next to the remove method, in this case, it's also a default method, okay? It's over here, it's just call the other non-implemented remove method, okay? And it also called that index off non-implemented method. Is it? So you can see the flexibility, is it, with the adds-on of the default method, is it just provide more flexibility. And in the other case, it also provide a lot of case when we design software, we also say it's compatible, is it? So compatibility. So it's compatible, is it, with other versions? Okay, so the default method in this case also pretty straightforward, is it? And we also have contain all method, and I define it as default. And here, and I recommend after you go home, you can try to implement this contain all default method. Okay, in our cases, in this linked list cases, you can try it. Okay, but anyway, here we still implement because we say, oh, it's always return true. Is it? You cannot, because this is a default method. Is it? So you must implement it. You cannot leave it empty. Okay, for this method. And same thing, add all. Is that we also just we didn't really implement, is it? We always make it return true, is it? So if you have time, okay, after today's class, you can try to implement all of this. It's going to be interesting. And the next bunch is remove all, retain all, is it? And next, let's see. And you will see in collections later on when we discuss. And it's also quite useful. It also provides a method called toArray method, okay? And this method will return an array. And the type is object. And this is also default method. And this is what I implemented, okay? So my version, okay? And if you have any other better version, you can try. So over here, what we did is we create a new array, is it, using call the new, and then you cast it, okay? Because over here, the type is E, is it? Because it's generic. And then you just call the get function. That get function is not implemented, okay? It's just then that method will purely, so this method is abstract method, is it? So it will rely on rely on concrete class who implements it. But anyway, here in this specific interface, is it because they all belong to the same interface? So this toArray method can still call that method, even though it's not implemented, okay? And then you can return this array. You just create it. So this toArray method, and we have another toArray, okay? So this is kind of a very general, you have an array and then you can return it. Is it do one by one item copy? But also be careful, okay? Here it's not a deep copy. So over here it's not a deep copy. Okay, otherwise you need to call the clone method, is it? Yeah, so that's the general idea about this my list interface. This is my list interface, okay? And it extends from the collection interface. And this interface today, the key point is it not just has a regular abstract method, is it? It also has a bunch of default method. And default method in the scenario of an interface is you must implement it. And when you implement it, you can call other. So this add method is not implemented, but this is allowed, okay, because they both belong to the same interface. You can call other non-implemented. Okay, so this is the first class not class, that's basically an interface. Next, let's see, this is our third version of linked list. And you can see it's quite long, okay. Let's see, then this interface. For this interface, then today what we implement, we not implement iterable, is that we implement the interface that we just defined, that my list, that, okay, and then in this linked list, we have some instance variables, still a node structure, okay? But this time we have two instance variable. We have a header, so the first, we also have tail. So we also have a node to remember who the last node is. And we also have another instance variable called size to remember how many items in the linked list. And for the default one, basically we didn't do anything. It's quite simple, okay? And then let's take a look at of the other methods in this linked list. For the second version of the constructor, what over here it did is going to create the linked list with an array, is it? And over here it's just keep call the add method. Okay, and later on we are going to see the add method basically implemented here. Okay, and then we have the get first method defined. So it just return whoever the first item is. So it's pretty straightforward over here. And then get last. The get last is also pretty straightforward because we have the last node. So just return whatever information in the last node. Okay, so nothing new here. Also, add first. Okay, let's see this add first. Let's go back to check. I don't remember if my list, what kind of add method. Oh, it doesn't. It has add method. It has add. Okay, it only has add method. Okay, and here we have the add first method. Okay, so this add first, based on previously we discussed, it's pretty straightforward. So you have this linked list. And in this case, it has a head point to the first node. It also has a tail node, okay? And suppose here is 100, is it? And add first what it means, suppose over here you want to add 50, is it? So you first need to create this new node, is it, with whatever information in this case. It's 50, is it? So this is our new node you create, is it? Then you need to set its next, is it? Point to head, is it? Point to head. And then you need to update the head, is it? You need to let head then repoint to the new node you just created, okay? So be careful, of course, over here, we also want to increase the size, is it? And the add first, also another thing we needed to be careful is if initially both head and tail, both of them point to null, is it? That means it's an empty list, is it? And if it's empty list, this case already taken care of. But remember over here, the tail part, you also need to take care of, is it? That's why both tail and head need to point. So this is our new node, is it? New node, so both head and tail going to point to this new node, okay? So that's what this add first did. And then over here, let's see, add last, is it? Add last here, this version compare with the version that, the other two versions that we discussed, it's much simpler, is it? Because we have the tail nodes, is it? So that's why over here, you just need to set the tails next, is it? So over here, you have, so over here, I have the tail, is it? So suppose this is 500, is it? Then I have this new node, new node. Is it? This is 600, is it? So what you do is you let tails next point to 600, is it? Then you need to reset tail to this new node, is it? So that's that step. And if the list is empty, and of course you need to set both head and tail to this new node, okay? So just be careful about all the cases, okay, when you do the linked list. And then next, let's see, this add, is it? This add method where it's defined. So let's go back to that interface, is it? That interface, yeah, that interface, my list interface. Over there, we define that add method, is it? You need to find the index, then you add it, is it? And that's why over here, I said, okay, I'm going to override it. Is it override? Override from where? From my list interface. So you implement here, is it? We implemented it here, okay? So for this one, it's pretty, the major concept is pretty similar as what we discussed in our previous discussions, okay? The previous two versions, similar, but the only thing is over here, you need first to loop to find the index, is it? So if index is 0, that means you're going to add first, is it? If index already greater than your size, that means you want to add at the very end, is it? And all of the other cases going to be add in the middle, is it? And if add in the middle, then like what we previously discussed. So we have like, suppose 100, 200, 300, 400, 500, something, is it? So you need to find the index, is it? So suppose the index is 3, is it? So you're going to have your, so this is, we call a cursor, is it? So here it's called current. So it will set it to the first node to head, is it? Then you're going to advance it, is it? So here we do the traversing, is it? So do node by node, is it? Visit. So over here, you know how many times you're going to loop. Index is 3, is it? So it's going to find 300, is it? Oh, find basically 200 over here, okay. So less than 3. So find the 200, is it? Find it, and then you're going to create the new node, is it? So we are going to have a new node created. Suppose it's 250, is it created? And then this is your current. So current is here at 200, is it? And then what you need to do is new nodes next set to, so you need first to set new nodes next to 300, okay? And then you set 200s next to this new node. Be careful, this is the first step, this is second step, okay? You cannot reverse. You cannot reverse both, okay? You need to first set new nodes next to 300 and then set currents next to 250, okay? And then in this case, you insert this new node between two existing nodes, and we also increase the size, okay? Okay, so that's the method we override, is it, from the interface. And remove first, so also nothing new here. It's basically similar as what we discussed previously, is it? But here you remove first, so if there is nothing there, of course you cannot remove, is it? Otherwise, and in this case, you also need to return the item, is it, the first item. So of course, so over here we have the list, is it? And so here is the head, is it? So this is the head's items, is it? So you're going to first get the item, is it? And because you're going to remove it, so that's why you need to set the head point to the second node, is it? And then basically the linked list, this guy is gone, is it? Even though it's still in the memory, okay, this node not really removed from the heap memory, is it? But the garbage collection will do the garbage collected, okay, if it's never referenced by any of the other variables in your program, then it will be garbage collected, okay. But anyway, your linked list then will start from the next node, okay. So that's, but also here's a special case you need to be careful is if you only have a single node, and if you remove first, of course, you need to reset your tail also to null, okay. So that's a special case we need to be careful. And remove last node, is it? Remove last node over here, it's the same thing. There are different scenarios you need to take care, is it? This is empty case, empty list case, is it? This is single node case. So you need to pay attention, is it? Because for single node case, then you need to set both and the tail to null, is it? After you remove that single node, is it? Otherwise, then in this case, is it? Because you're going to remove the last node, is it? So you need to find where the last node is it? So that's how over here you're going to do the loop to find the last node, is it? Then what you just do is you just reset the tail, is it? Reset the tail node to the previous one, not to the last one, is it? And then reset its tail to the next, is it? So here the idea is, so if you have, so this is our linked list, is it? In this case, this is going to be the current, is it? The second last node, because you want to remove the last node, is it? You want to remove the last node. I'm sorry, the current, yeah. The current is going, and then you reset your tail, is it? You reset your tail to this second last node, is it? To the second last node. And then what? And then you reset. So this will be gone, is it? And you reset this next to a null pointer, is it? To a null thing. Okay, so that's remove last. And then next, let's see, we call the remove method, is it? And remove method comes from where? Comes from that interface, is it? In that interface, you just define it, is it? You never remove it, is it? Over here, we implement that remove method, okay? And this is going to remove wherever you specify, is it by the index, okay? And over here, just take care of a different scenario, is it? If your index is out of bound, then you don't do anything, is it? And if your index is the first one, you call remove first. If your index is the last, you call remove last, is it? And then it's going to be the case. So over here, it's a case that you're going to remove in the middle, is it? Whenever we want to remove the node, not the first, not the last. You remember previously we discussed, is it? Then you need to do the pair advancing. Pair advancing, is it? So basically you need to have a node, is it? So suppose this is a current, is it? And then you also need to have that previous one, is it? The one ahead of it, is it? Then in this case, what you need to do is, because you're going to remove this one, so you reset its next, two currents next, is it? Two currents next, okay? And then this one is automatically gone. It's going to be garbage collected if it's never referenced by anyone, okay? So that's remove. And the toString is also similar as what we previously discussed, okay? So nothing new here for the toString. And the clear function. And over here, it's pretty straightforward. You just reset both head and tail to null, is it? And the contains method is kind of search, is it? A search. So basically, this is you also override the interface one, because it's defined in interface, okay? So defined in that my list interface, is it? And then over here we implement it. But you want to check if your linked list contains this item, is it? So that's why you need to use a loop to see if that item is in your list, okay? Over here, what we do is basically also the traversing, okay, as what we previously discussed. So nothing new here, okay? So this is a contain method. And the get method, is it? It's similar as the contain, is it? But here you have the definite number of loop, is it? So that's why we use a for loop. Not like over here, you don't know how many times it's going to iterate, is it? So that's why you use a while loop, okay? And the index of, it's similar, is it? So you need to find where the item is it? Where the item is. So we also use a while loop, is it? To do the check, do the traversing, okay? So it's similar. And the last index of, okay, last index of, then it's the same, you use a while loop, it's a loop through the end of the linked list, is it? And then you just try to do comparison. But over here, be careful, is because it's find the last index of. So it's not, generally, a lot of time when we do searches, once we find, then we return, is it? Here, no return, is it? You just keep changing, keep updating this return index. Is it? You just keep updating, is it? You need to finish your loop, is it? And then you return that index, because this is the last index of, okay? Okay, so then what the next is about the set method, is it? So the item from that index, and then you just update its contents, okay? Nothing new here. And for this for this version of linked list, it's similar, is it? We still provide the iterator method, is it? And you may say, oh, this one didn't implement iterable interface, is it? But you remember it implements what? Implement my list, is it? My list implement what? So basically the hierarchy here is iterable. Iterable, is it? Then go to collection in our version, okay? And then we have my list, is it? And the iterator method is from the iterable interface, okay? And because this hierarchy relationship, is it? So that's why over here you can still implement your iterator, okay? Then so that you will be able to specifically do the iteration, is it? And similar over here, we also define our own version of the iterator. Is that iterator will implement the Java provided iterator. And what this iterator is, basically it's the cursor. Is it like what we previously discussed? Okay, you initialize it as well as the head. Is it the first node of your linked list? And it's similar, you need to implement the has next and the next method. This is the same, exact same as what we discussed yesterday. But over here for this version, we also provide the remove method. Okay, the remove method. The remove method, what it did is pretty similar as what we discussed for our remove method for the linked list, is it? So you start to loop, is it? You start your loop, and then you try to find where your current is it? And then you can remove it. Okay, so this whole implementation basically it's pretty similar as linked list remove. Okay, but be careful. This remove is iterators. Is iterators, okay, not linked list, okay. So over here it's needed to find the current, is it? The current basically is what? Is iterators location, is it? The position pointer, okay. And then it's going to return that one, is it? If you return that one, that's why you need also to update it, okay. So that's the whole idea here. Okay, and the node structure is also pretty similar as what we discussed before, is it? And it has two parts, the node. It has the information part, it also has the next part, okay? And over here, it also overrides the size function. Okay, so you can see this version of linked list, it's quite comprehensive, is it? So today's linked list implementation is quite comprehensive. So basically, we kind of get a glimpse of what Java's provided linked list, because next week we are going to learn collection libraries linked list. Basically, this kind of give you the idea how that one is implemented. And let's take a look at the driver part. Okay, so for the driver part, it's pretty straightforward. We have a string linked list, okay? Then we just call the add method, is it? And we can also do the printout of the linked list. And we didn't, we implemented two strings, so it will follow whatever we define, is it? So here it call add last, is it? And with whatever index, then you add some item, is it? So nothing new. You can also remove, is it, some item. So nothing new here. And the same thing here, be careful, is it? And here, why we can do this for each loop? Not sure if you still remember. And why we can call this for each loop? It's because that iterator method. Okay, that method already implemented, is it? Because this this linked list implements the collection interface. Okay, that's why you can do that. And over here, you call that to array, is it? And for array, you can also do this for each loop, okay? And over here, we call the contain method, so nothing new. And here, we try that set method, also nothing new here. And over here, let's take a look, okay? So over here, you call the iterator, is it? This iterator basically will give you where the first node is in the linked list, is it? And then you can see over here, basically, you just literally do node by node visit, is it? And then try to do something. And over here, be careful, okay? Why we see, why sometimes you need to provide your own version of that iterator. Okay, so here, let's see. For this version of iterator, we have the specific has next and the next. Is it? And the next. And what over here you try to see is, oh, I want to try to see if there is this specific phrase. Is it? If it is, I'm going to remove it. Is it? From my linked list. And of course, you can call the linked list to do remove, is it? But over here, what I'm trying to achieving is I'm going to use that iterator, is it, to do the remove, okay? And once you remove, this loop will not be terminated. Will not be terminated. So it will continue, okay, after it removed. Okay, so here let's explain the concept here. So just think about it. So here we have the linked list, is it? But if you use for each, then that won't work, okay? Or you use some for loop. Suppose you use, we use our very traditional way, I equals 0, then let's suppose this list size function. Okay, then I plus plus, is it? Then how many times? 1, 2, 3, 4, 5, is it? So this loop has definite number of iterations, is it? It's 5. It needed to iterate 5 times, is it? But over here, the story is going to be different, is it? Because you just think about it. Once you remove this item, then the list size is going to be changed. Is it? List size change it to what? Change it to 4. Is it? But when you use a for loop, you cannot change this one. Is it? So it will have issue. Okay. It will have issue. So if you have the for loop, the definite loop, and then you want to call remove. So over here within the loop, then you call the remove. That will cause the loop issue. Okay, so be very careful here. But if we use this kind of while loop, that won't break. That won't break it, because what it does is once it finds the current, is it? And it will automatically know the next. So it will remove automatically, is it, over here with this next. So it will be taken care of so that you don't need to worry about the loop got changed, okay? So be very careful when you use, when you have any remove operation. Okay, so then you better choose like this kind of loop. Okay, then it won't break your iteration. That's the concept here. And then next, let's see. So over here is just the for each loop. Okay, for each loop. So basically, and over here it's called the clear function. Okay, so that's all the overall the information about today's discussion. And do you all have any other questions? Is everything good? I know today's contents may be hard to absorb very quickly, okay, because there are too much information. So any other questions?